Hey, good day everybody. Today is the Christmas day of 2018. I wish you here Merry Christmas and Happy New Year. We present several movies, all of them are quite high resolution, and some customers ask me, like, what are those foundation of high resolution weighing? And I will say, first of all, the structure. For example, the structural strength of a weighing platform and the load cell. Okay, well, the concern about load cell, we don't need the excellent load cell. What we need is load cell with very stable performance. And then we have the connection. Okay, for example, the connection between the load cell platform and the indicator. And also the electronics are very important. Concerning about the electronics, okay, first of all, we need to have a good ADC, and which is good in EMC performance. And of course, the number of bits should be as high as possible. And for your information, all the ADC or AD chip we use in our products are all 24-bit. And then the program itself. Talking about the program, okay, there are several techniques, okay. For example, how good you are in the squeezing the number of bits from the AD chip, and then the method you use to stabilize the AD count from the AD chip, because usually the AD count from the AD chips go up and down like this. That means that you have to use a very smart method to handle the AD count. And also for the circuit itself, okay, you have to plan your circuit layout very good, because while some EMC interference will affect the stability of the high resolution weighing equipment. Okay, I have here mainboard which we use for our this mainboard is from the model of one of our model 10,000 approved model, OIML approved model. Okay, I am doing some observation on it, so I just present it this way. Okay, as you can see, there is no metal cover on the AD section. Okay, and I use a very loose connection. Okay, loose connection. The mainboard is now in internal count mode. Now we have 1,000,000 and 1,700,000 something thousand. Okay, internal count. Okay, I just mentioned. Okay, you need to have good ADC and a good method to handle the AD count from the AD chip. For example, the simulator now output is 80%. Okay, I do it here. I do it at 60% output of a 2 millivolt per volt load cell. And now the AD count is 1.3 millions plus 2,000 something. As you can see now, the AD count is quite stable. For example, at this output, the total number of E is 200,000 E. That means that for each E we have 15 count. That means that when it changes, okay, 15 count up or 15 count down on the display, it will have 1 E plus or 1 E minus. So the ADC now is output is very good. Of course, while we talk about EMC performance. We do not have the official equipment to test the EMC performance, but I try to follow the old way, okay, call in and call back method, which we use from time to time. How to unlock my phone? And then call me. Call. Okay, the AD is still stable, so at least at this frequency range, the circuit layout is good. Let's hang up and I call back. One moment. Okay, I call back. A very familiar and old tune. This is the traditional Nokia tune. Well, be honest. I'm not an iPhone fan. I'm a Nokia fan. So I'm very happy that the Nokia is now back to the market. Okay, if you have the electronics, okay, if you select the correct component and you have a good circuit layout and you have a good enough program, then you have almost all the foundation necessary to have a very high resolution weighing application. For example, if you make everything correct, then you have something like this. Okay, let me 0. I need 100. I give me another 200. Okay, you have something like this. Okay, thank you for watching. Once again, Merry Christmas and Happy New Year. Bye bye.